We're going to do some more practice drawing Venn diagrams. In this case, our universal set is the natural numbers from 1 to 40. So remember that we draw a large rectangle to represent our universal set, and we put the uppercase letter that represents our set in the top right corner. So we're going to put a U in the top right corner to represent all natural numbers from 1 to 40. Now we have three subsets here. We have the subset A, which is multiples of 4, B, which is multiples of 6, and C, which is multiples of 17. So I know I need to draw 3 circles within my universal set, but I need to decide if any of my circles should overlap. Are there any elements that are going to overlap between set A, multiples of 4, and set B, multiples of 6? Now, I can think of one off the top of my head. The number 12 is a multiple of 4 and a multiple of 6. So I know there's going to be some overlap between sets A and B. So when I draw A and B, I'm going to draw them so that the circles overlap and there's some elements that are common to both sets. So I'm going to label one set A and the other set B. Now with my third set, C, again, I need to decide if there's going to be any overlap between the sets. If I'm thinking about the set C, multiples of 17, I have 17, and the next multiple of 17 is 34. And those are the only two elements that exist between 1 and 40. Remember that our universal set are the natural numbers from 1 to 40. So there's not going to be any overlap here. 17 and 34 are neither multiples of 4 or multiples of 6. So C would be disjoint from A and B. There's no common elements between C and A nor B. So when I draw C, I'm going to draw it separate from A and B. I'm going to draw it so that it's not overlapping. And I'm drawing it quite small here because there's only 2 elements in set C, although the size of circle doesn't matter. Okay, and so now let's kind of fill this in. If I'm thinking about the elements that exist in set A, there's going to be 4, 8, 12 is going to go in the middle because 12 is a common element to both A, multiples of 4, and B, multiples of 6. The next multiple is going to be 16, 20, and the next multiple of 4 is 24. Again, it's going in the center because it's common to both set A and set B. Okay, the next element is going to be 28, 32, 36 goes in the middle because it's also a multiple of 6, and the last element is 40. Now the elements that go in B are going to be my multiples of 6. So 6, 12 is already in there. It's in the center because it's also a multiple of 4. So 6, 12, 18, 24 is already in there. And the next one's going to be 30, and 36 is already in there. So I've completed all my multiples of 4 and my multiples of 6. My set C only has 2 elements in it, 17 and 34. Now, let's just state a few conclusions from this information. So some conclusions that we could make are that sets A, B, and C are all subsets of U because they all exist within the universal set of U. Okay, if we wanted to write these out, we could say that A is a subset of U, we could say that B is a subset of U, and we could say that C is a subset of U. Some other conclusions that we could make are that in set A and set B, because there's an overlap and some elements exist in both sets, we would say that these are not disjoint. So set A and set B are not disjoint because they have some common elements. Okay, and we could say that set C is disjoint because there's no common elements with any other sets. So set C is disjoint from set A and set B. Now the next question asks us, what is n of A? Now remember that this notation means what is the number of elements in set A? What is the number of elements in set A? So all we need to do is count them. So I'm just going to put a dot as we're counting. So we have 1, 2, 3, 4, 5, 6, 7 that are in just only A and not B, but within set A is anything in the circle that represents the set A. So we also need to include our 12, our 24, and our 36, which means that the set A contains 10 elements. So the number of elements in set A is 10. The next question asks us, what is n of A prime, or what is the number of elements in the complement of A? Now remember that the complement of A is everything that is not in the set A. So any elements within the universal set that are not in the set A. So what you want to do is you want to take the number of elements in the universal set and you want to subtract the number of elements that are in A, and that will leave you with the number of elements that exist once the elements of A are removed. So if we take the total number of elements in the universal set, which is 40 numbers, and we take away the 10 elements that are multiples of 4, that's going to leave us with 30 elements that are not multiples of 4. So 30 elements exist in the complement of A.